All right, this video is going to be over composition of functions or functions within other functions. The very common notation that you'll see for composite functions is this F and then open circle G inside the parentheses as the algebraic operation that you are wanting to do. And the way that we should then rewrite it as is of the right hand side. So more it's like f of g of x is what we want to look at. Now, one thing that's important is you're going to plug x into g. And then those outputs of g become the inputs of f. So if we had like a table, right, we normally would have like inputs and outputs, but then those become like second inputs that get like final outputs, if you will. Another thing that's important then is the range of G ends up becoming the domain of F. So if G has any restrictions on its range of G becomes the domain of F. So if we have any weird like range restrictions on G, then that's going to then get plugged into F. So we just have to be kind of careful there. All right, so one thing that I want us to look at is that we might not always get the same function if you do f of g of x and g of f of x. Like, it is very possible that you get two different functions and that you can't just like call them the same thing and switch them around. So if I wanted to take f of g of x, then that's f of 3 minus x. And so everywhere I see an x in f of x, I plug in 3 minus x. So I get 6 minus 2x plus 1, which would be 7 minus 2x. If I wanted to find g of f of x, then I'm going to plug in g of 2x plus 1. And so that means I'm going to do 3 minus, and then I'm going to plug this in for x. And then that gives me 3 minus 2x minus 1, or 2x minus 2. And then those are not equal to each other. So that's just one example to make sure that we see that you can't just like switch these around, like the order of operations matters. And this is a good way to make sure that you do that correctly, is rewrite it as f of, and then plug in there, g of f of x, plug in, and then plug in here. All right, let's look at another example where we're looking at a table and make sure that we understand how this would go. So if I wanted to find f of g of 3, well, that means that x is equal to 3. And so I'm trying to find f of, what is g of 3? G of 3, it looks like, is 2. So then I'm going to plug that in. I want to find f of 2. So f of 2 gives me 8. All right, let's go the other way. G of f of 3. All right, well, f of 3, it looks like, is 3. So I now want to plug that in. F of 3 equals 3. So that's what goes in right here. Just like 2 went in there now. 3 goes in here. And so I now want to find g of 3, which gives me 2. All right, now let's go ahead and look at this problem here. So f of g of x, we want to look at the domain, and I have two different square root functions. So let's first look at this notation, right? F of g of x is f of g of x. And so let's look at the domain of g of x. So this would be the square root function. I'm going to actually write it like this, negative x plus 3. And remember, we have to take that -1 out to make sure we have our reflection and our move and all of that. So this says take the negative and move to the right 3. So reflect and go this way. So the domain of g of x is that x must be greater or less than or equal to 3. However, notice that the range of g of x is y is greater than or equal to 0. Well, then that's going to be what I find is my domain up here. So let's make sure I can plug that into f of x and don't have any issues. So remember, the range of g of x becomes the domain of f of g of x must be these numbers here greater than or equal to 0. Well, then that's going to be just fine plugging in here. So we're not going to have any issues plugging that in. And so we can say that our original domain, x less than or equal to 3, ends up working out just fine, because I can plug those numbers into g of x. Those numbers can get plugged in here and everything works out okay. And so our domain is going to be just fine